Hello Pre-Calc. Here we go. We're going to get a little more into our trig identities. So we are going to apply some of the properties you got in the last lesson. So using the quotient and reciprocal properties as well as your Pythagorean identities, we are going to transform sine x cotangent x into cosine x. Yes. So how do we do this? Well, we start off with our given, which is this. And then what I like to do is turn everything into sine and cosine. So sine x can stay just as it is. Cotangent, remember, is going to be cosine x over sine x, which means the sines are going to cancel, and we are done. That was a nice, easy one. All right, so that would be using your reciprocal properties. Now we are going to transform an identity that you're going to get later on, which has actually three versions of its identity. So this will be how one of the versions will turn out. So it's always helpful to look at what you're given and where you're going. So notice I have sine squared in both my given and my final answer. So probably I don't want to touch that. I'm going to be able to use that. So we start with cosine squared minus sine squared. So what I am going to do is I'm going to replace cosine squared with its Pythagorean identity. So remember, this is equivalent to 1 minus sine squared x. And we still have this sine squared x here. And then if we just combine our like terms, voila, we've got what we wanted. All right? So that would be utilizing your Pythagorean identity. And remember, that's why we went over all three different versions, because you want to be able to recognize it in different forms. Now we are going to take straight up tangent. Now this is one of the properties you were given, but we're going to show how we get it. So we start with tangent, and then I'm going to rewrite tangent in terms of sine and cosine. That's using the quotient property. And now I'm going to utilize the reciprocal property. The reciprocal of sine is cosecant. So what that means is cosecant would go downstairs. The reciprocal of cosine is secant, which means secant goes upstairs, and that's what we're trying to prove. Okay? All right, now, when you are doing identities, this is kind of like teaching geometric proofs. I can give you some strategies, which is what this lesson really is about, the different kinds of strategies. But the idea is you're only allowed to start with one side and work on one side. Although in reality, sometimes I might try and do a little back planning. But in the end, you should really only be touching one side. So I want to prove that this product equals sine squared x. So hopefully you notice this is sort of a difference of squares formula. You have a minus b times a plus b. So that's what I would start with. And that means if I FOIL those together, I get a squared minus b squared, which is 1 minus cosine squared x. And hopefully then you recognize that is one of our Pythagorean identities that we just used up ahead, except we did it as 1 minus sine squared equals cosine. Now you have the other one. And that was it. Pretty nice, okay? Now this next example, example 5, this is a really, really common type of problem. And what the strategy here is going to be are conjugates. And again, we can only work on one side, and in this problem, it really doesn't matter which side you work on. So I'm going to work on the right-hand side just because I can write off of it. Okay, so it's as if I started with, well, why don't I do this appropriately? So we're going to start with, I'm going to write it up here, sine, hello, where's my pen? Sine beta over 1 plus cosine beta. That's what we're starting with. And so we want somehow to get down to 1 minus cosine in the numerator, sine in the denominator. Well, what we're going to do is we are going to multiply top and bottom by the conjugate. So this will be 1 minus cosine beta, and this, so we're multiplying by 1, which means we're not changing the value of anything. So you're always, this is going to be a little classic problem. You multiply by conjugates, then after you FOIL, you will apply your Pythagorean identity, and that will allow you to solve the problem, as you will see. So that was our first step. So then what does that give me? Well, on top, it gives me sine beta over 1 minus cosine beta, and I'm not going to do anything with that. I'm just going to leave it as is for a minute. On the bottom, again, we're going to get 1 minus cosine squared beta, and that's just FOILing and using your difference of squares pattern. All right, well, that's nice. Then we use our Pythagorean identity. So on top, I'm still not touching anything. This is going to be what was. But on the bottom, I know that that turns into sine squared beta. And that means this will cancel with one of those. And that is our final answer. That's what we were after. That is going to be a very typical process. You multiply by the conjugate, you do your FOILing, you use your Pythagorean identity, and then things cancel. Especially when you see this sort of one side has the 1 minus and the other side has the 1 plus on the opposite part of the fraction. It's always the way I would attack that problem. Okay, in example 6, what we're showing is that somehow you are going to take two terms and they have to become one term. Well, how do you take two things and make it into one? That means you're going to need a common denominator. So before we can even get there, I sure didn't give myself a lot of room here, did I? Because I just took up my space on the other side. That's okay, we can squeeze it in here. So I'm going to start with 1 plus tangent squared. And again, you're proving the identity. That means you're not allowed to use the identity in the proof. So my first step is this. My second step is going to be rewrite tangent squared as, whoops, almost wrote it as the wrong thing, sine squared x over cosine squared x. All right? Okay, well that's nice. Again, you have two terms, you want to make one. So what I'm going to do is rewrite one as cosine squared x over cosine squared x, but that now is our common denominator. And since I'm running out of room, I hope you'll forgive me for kind of skipping a step there. I would usually just write cosine squared over cosine squared plus sine squared over cosine squared, but then you join them together with one common denominator. Notice on top I have cosine squared plus sine squared, which is equivalent to 1 over cosine squared. And we know that 1 over cosine squared as a reciprocal is secant squared. And voila, we are done. All right, so whenever you have two terms that you want to turn into one term, you are going to need a common denominator. That will be a general strategy. Okay, we keep going. And again, you know what? It's not a bad idea for you to turn off the video and try these on your own, and then just kind of double check and see if you got it. So we have tan cosecant. So again, two terms, although really this is just one term because there is no plus or minus. So I'm not going to need any common denominator. I am going to want to put them, use your reciprocal and quotient properties though. So as usual, I'm working on this side. So I'm going to rewrite tangent as sine x over cosine x and cosecant as 1 over sine x. And that allows me to cancel those so that I have 1 over cosine x which equals secant x. And that is what we wanted. All right, over here, notice I do have two terms. There's that plus. So at some point, I am going to use a common denominator. But let's first put everything in terms of cosine and sine. So I have cosine x times cotangent is cosine x over sine x plus, now, sine x, I need a denominator because this is just sine x over 1. So I'm going to multiply top and bottom by sine. So it makes it squared on top, but gives me that common denominator. All right, so I kind of took two steps there as once, but it was different steps to each term, so I think that's okay. So now we can kind of simplify this. We have cosine squared x plus sine squared x on top over a common denominator of sine x, and we know that's going to equal 1 over sine x using your Pythagorean identity. And that gives me the reciprocal of sine is your cosecant, which is what we wanted. All right, so we continue with our strategies. So in this next one, notice I do have two terms that has to go into one term, but in this case, I'm not going to do a common denominator. I am going to pull out my greatest common factor because I have a sign that is common to both terms. So when I pull it out, I get 1 minus cosine squared x, and we know that that in the parentheses is equivalent to sine squared x using your Pythagorean identity, and then I can bring everything together, and that would be the end. All right, so before you just figure you're going to use common denominator, look for that GCF to pull out, because quite often what is left, you'll use the Pythagorean identity on it. Now, this next one, this is a huge concept in calculus in terms of simplifying big rational equations to break them up and make them easier to work with. It's what I call singletons. So it's the opposite of finding a common denominator. Remember, when you have a common denominator, two terms become one. But now we're going from, because I'm going to, well, and we could do this problem both ways. It doesn't matter. I am going to start on this side. So what that means is I'm going to break this up as if it had, like the step before, obviously I can't talk, 1 over sine theta plus cosine theta over sine theta. It's like finding a common denominator backwards. What was the step right before they came together? So we took that singleton and we broke it up so that each numerator shared that denominator. Ah, look at what that does. 1 over sine is the same thing as cosecant theta. Cosine over sine is the same thing as cotangent theta. And voila, you are done. That is it. But let's say you wanted to work on this side. So let's do that over here. This is a testimony to having really good, so basically you're going to do the same thing backwards. Again, I need that common denominator. So this is 1 over sine theta. This is cosine over sine. We have our common denominator. And when we put them all together, voila, we are done. Okay? All right. Now, this has two steps to it. I know it says their common denominator. Yeah, I guess I'll just do that because, and again, doesn't matter which side, but we do have two terms that are joined by the plus or minus, and it does have to become that one term, 2 cosecant x. And 2 cosecant is so simple, it's like, how do I break that up and get something big and ugly? So we work on the uglier side usually. All right, so if I wanted a common denominator, that means this one would get multiplied top and bottom by sine. This one would get multiplied top and bottom by 1 plus cosine. All right, we have a common denominator, so let's simplify it out. I've got sine squared x plus, and I'm going to FOIL this out, that's going to give me 1 plus 2 cosine x plus cosine squared x. I've already added the two middle terms, and that is all going to be over our common denominator of sine x 1 plus cosine x. And I'm not going to distribute that through because I'm hoping something will cancel. All right, so we look at this. Hopefully you noticed this. Hopefully you noticed this. So I can put those together as 1 because sine squared plus cosine squared is 1. So we have 1 plus 1, which is 2. I really don't need to make an extra step out of that because that's just kind of silly. So 1 plus 1 is 2 plus 2 cosine x. Don't want to take too many liberties all in one step. So one of those ones came from sine squared plus cosine squared equals 1. All right, well, we're not quite there yet. So what I'm going to do, again, there's that GCF in my numerator. I'm going to factor out a 2. Ah, look at that. Dun, 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 dun. So I have something, since it is in parentheses, that means everything's multiplication. Those will cancel. And I've got myself 2 over sine x, which is, we know, the same thing as 2 cosecant x, which is what we wanted. So we are done. Awesome. All right, and then here is that concept again, the conjugates. Again, notice you have 1 plus sine x in the denominator, but 1 minus sine x in the numerator. That's what happens when you multiply something by the conjugate. And again, I'm going to work on the left-hand side just because then there's space for me to work on. Again, you do not multiply by the same thing, you multiply by the conjugate. And you have to multiply by 1 so you don't change the fraction. All right, so what does that give me? On top, that gives me 1 minus sine squared x over cosine x times 1 plus sine x. All right, that's nice. So just like before, conjugates always turns into a Pythagorean identity. So I now have cosine squared x on top over cosine x. You're going to find these are always the same strategy. So one of those will cancel with that. And what color am I in? That gives me my final answer, cosine x. And again, in these problems, it really does not matter which side you start working on. It will always be the same strategy. Okay, so now setting you free. Again, now here's where I would really recommend you just turn off the video and try these on your own. But I'm going to keep going forward. So again, I'm going to start on the right-hand side. 1 plus tangent squared, well, that is one of my Pythagorean identities. So that's going to become secant squared. And I have cosecant x times secant x in the denominator. So one of these goes with one of those. That leaves me with secant x over cosecant x. And I really would like to see you guys break it all the way down to sine and cosine. So the reciprocal of cosecant is sine. So sine's going to go on top. The reciprocal of secant is cosine, so it goes in the bottom. And we know that sine over cosine is tangent. And to finish us off, now again, it really doesn't matter which side you work on, but I'll stick with the right-hand side. And I'm going to multiply top and bottom by the conjugate. So I will start with that. And that's going to get multiplied by cosine squared over 1 minus sine theta. So remember, every time you multiply by that conjugate, this top one, I'm going to leave it as is for a moment, so that I can FOIL the denominator, which becomes your difference of squares, And that always turns into your Pythagorean identity. But we got to write out this numerator first. So the denominator here is cosine squared. Ooh, this time everything canceled. That was really satisfying. And we are left with just 1 plus sine theta. All right, so the idea behind this was to show you some of the common strategies. That's really all we can do because every proof has its own little twists and turns.